Welcome, my dear students and my viewers. Today I have brought for you an important video. I know your exams are coming, so I have brought for you 10 most important multiple choice questions for exams, which I have taken from the topic of probability and measurement. So this video is going to be really helpful for grade 9 and 10. So if you have not subscribed to the channel, please subscribe to the channel so that you receive all the updates. And now let's get started with this video on probability. Let's see the first question for today. In this question, as you can see, there's a spinner. It's a spinner problem. The spinner above is spun twice and the product of the two numbers obtained is recorded. What is the probability that an odd number is not recorded? So if you see the word not is mentioned, so that means you have to apply for this question the concept of complement. So let's see how we are going to be doing this one. Now the spinner is spun twice. Twice means it is two times. Let me highlight the keywords. And the product of the two obtained number is recorded. What is the probability that an odd number is not recorded? That means the product has to be not odd. So what are the options? The options are that it will be an even number. So that is possible if both the numbers which have come in the spinner are coming as even numbers, right? Because what is the probability that an odd number is not recorded? So let's find the probability that an odd number is recorded and then we'll take the complement to get the answer. So probability of getting an odd number, let's find. So out of 1, 2, 3, 4, 5, 6, how many are the odd numbers? Let's write them. 1, 3, 5. How many are the even numbers? Let's write them too. 2, 4 and 6. So probability of picking an odd number is 1, 2, 3. 3 options out of total of 6. So the probability is 1 by 2. And if you look at the two events of spinning, then these are independent. There is no relation between them. So can we say the product of getting the probability of getting an odd number in both the throws is independent? Yeah. So for the first it is 1 by 2, for the second also it is 1 by 2. And because these are independent events, we are applying the concept of multiplication rule. So this is 1 over 4. And this is probability of getting odd number twice in both the trials. So we need not odd. That means the odd should not come. So probability of not odd. So this is complement. So 1 minus probability of getting odd. So 1 minus 1 by 4. So we have applied the concept of complement. So the answer is 3 by 4. C. So as you can see, they have done the same thing, taken the product rule because these were independent events. So I hope this one is correct. This is how you should answer the question. I've given you the reasons and the justification. Move to question 2 now. So let's solve now the next question, question number 3. Okay, so let's solve the next question. This question is on geometric probability. I want you to read the question nicely, highlight the important information, and also notice that in this question you are already given the figure. That will really help you. So a point X is chosen on random at RH. So anywhere in between it can be chosen, and it is known, there's a condition given to you that the probability that this X is going to be on RH is 3 times the probability X is on NH. So this is very important. You need to find the length of NH. NH is not given, so let's take that as X because we don't know the value of X. So if your NH is X, then we can say RH is equal to 6 plus X or X plus 6 because Rn is given to you as 6. Okay, now you can take the ratio. The probability that a point is going to be on a segment by the definition and the formula of geometric probability is going to be equal to the length. So the probability that x is going to be on nh, I'm trying to find this. So the smaller line segment NH divided by the total, that is RH. This is the formula of geometrical probability. So this is x over x plus 6. So we have calculated the probability that x is on NH. So we can plug it now here in this formula for probability that x is on RH. Now because it is given to you in the question, if you read properly, that x is chosen at random on RH. So it's a sure event. It is going to happen because the condition is already given. So the probability that x is going to be on RH, this probability, because it's a sure event, is going to be 1. So that's why 1 is equal to 3 times, and then we have put in the value. So this step comes from there. Now just simplify, cross multiply both sides, and your x comes out to be 3. So that's how you get the length of NH. I hope this is clear. And what concept we have used here? Geometric probability. So this formula is the formula that we've used for geometric probability, where you take the probability as the ratio of the length of sides. Let's move to the next question now, question number 4. So first I would want you to read the question. Okay, so let's read the question. There are two sets, set 1 and 2, given to you. You have to tell which of the sets out of these two is countably infinite. Okay, so let's look at the sets one by one. For set 1, how many elements are there? I want you to count 3 elements. So you can count them. So this is going to be a finite set. So definitely set 1 cannot be the answer. So this crosses, this crosses. A and C cannot be your option. Now let's come to set of natural numbers. So natural numbers are so many, you cannot count them. So this is definitely going to be a countably infinite set. So yes, the option which has 2 is going to be correct. So yes, B is going to be the answer, correct one, because set 1 is finite, set 2 is infinite. Okay, now we move on to question number 5. So let's see the question. Let's read it properly. So SI has 5 red and 4 blue marbles in a bag. Without looking, he takes out one marble. Then without replacing the marble, he takes out another marble. What is the probability that the two chosen marbles have different colors? So let's underline important points. 5 red, 4 blue. Then without looking, he is taking out one marble, okay, and without replacement. So this question is a question on without replacement. So because you're not replacing back the marble that you've drawn, so the sample space will get affected. It will get reduced, okay. That is one important point in the question. What is the probability that the two chosen marbles have different colors? So let's draw a rough figure here. 5 red, 4 blue, so total are 9. Okay, so the what is the probability that the chosen marbles have different color? So either one will be red, other will be blue, or the first one will be blue or the other one will be red. So that combination will be in the favorable outcomes. So let's see how we do it. Since they are not replaced, the sample space reduces. Already I've told you that. So first you can have red, second you can have blue, or these two options. So choosing two different marbles, the probabilities, because these are going to be affected, so the first red can be 5 over the total 9. Then for blue, it will be 4 over 8. And then you add it to the other option where one is reduced, and then you have first blue, so 4 over 9, and then it reduces, so 5 over 8. So now just add them both. So the total on simplification is 5 over 9. So D is the answer. Do now the next question, question number 6. I want you to read it carefully and then tell me which option is correct. Okay, so let's now have a look at this question. Here a table is already given to you of values. As you can see, Here you have on the rows juice and soda, on the column you have pizza and burger, and then finally the total at the ends. So Aisha is planning a party with 20 of her friends. She asked them whether they prefer to eat pizza or burger. So there are two options here. And then for drinks also, either juice or soda. There are two options. And then you're recording it, everything on the form of this table. So one of our friends who prefers to eat a burger is chosen at random. So this condition is given. Can you see? So this is a question on conditional probability. It's already given to you that the person is taking burger. Now the option is only for the drink. So what is the probability that she prefers to drink soda? So once she has taken the burger, that means we are looking at this column where the total is 9 options, and what is the probability that she prefers to drink soda? So I will change the color here. For soda, this option, that means this is the favorable outcome. So favorable is 5, total is 9. So definitely the answer will be C. We have question number 7. Let's do this one now. Okay, so next question. Nadia has 5 different types of fruits in her fridge. She wants to choose 1 or 2 types of fruit to make juice. How many different juice she can make? So there are again 4 options, out of which A is correct. Now let me give you the reason and the working. So number of juices by choosing one type of fruit. So there are 5 different types of fruits, out of which you can choose any 2 fruits to make the juice. So 5C2. We are going to solve this by combination because order of choosing the fruit is not important. So 5 factorial over 2 factorial multiplied with 5 minus 2 factorial. So here you have used the formula of combination. Let me write the formula in case you've forgotten. NCR, the number of ways in which R options are chosen out of total n is given by NCR. So n factorial over r factorial multiplied with n minus r factorial. So 10 is going to be this simplification. Now, number of ways of choosing 1 or 2 types of fruit. So there are both options. Either you can choose 1 also, or you can choose 2 also. Both are given. So remember, when you have or, it means union, and union has the rule of addition. So addition rule will apply when you have a union question, and if it is and, it means intersection, so multiplication. So because here it is asking 1 or 2, this is the keyword here. So or means union, so you are going to add the 2 probabilities. That's why 5 plus 10, which gives you 15. So you used the addition rule of probability. Let's do now question number 8. So in question, you are given this circular disc and the figure is already given to you. A point is chosen at random in this figure. What is the probability that the point lies in the blue region? That means that point should lie in this disc. Let me change color. Yeah, so this disc that you see. So I hope you are able to identify. Again, this is a question on geometric probability where we had done the area formula. So let me give you the simplification how the answer is seen. So the probability that the point lies in the blue region, that is given by this disk. So you have to take the big circle, subtract the area from the small circle, and that's how you get the area of this disk. So the area of disk, the blue disk we are talking about, because that is what is asked in the question. So area of a circle, I hope you remember, is pi r square. The radius of the big circle is 3 plus 2, 5. So that's why pi 5 square is the area. And from that you subtract the area of the smaller circle minus pi 3 square. So that gives you the area of the disk, which is on simplification coming out to be 25 minus 9 divided by 25. So just cancel the pi from there, and 16 over 25 is the answer. Okay, question 9 now. A and B are independent, not mutually exclusive events. So these keywords are very, very important. You know what are independent events. We've done mutually exclusive. In case you have forgotten, please do watch my previous videos. I will put the link in the description box. And here you are given the probability of both event A and event B. What you need to find? Probability of A or B. So A or B means you have to find the probability of the union. Okay. Or is the keyword. And here, because the events are given to be independent, that means the multiplication rule that we have done is going to be applying. So for independent events, multiplication rule works. That means probability of A intersection B is the product of the probabilities. Just multiply 1 by 4 with 1 by 3, so you get 1 by 12. Now A and B are not mutually exclusive. That means the rule, the formula, this is very, very important. 100% in your exam, a question is going to come which will use this one. Generally, you get a word problem or you get a problem like this also. Okay, so probability of A or B is asked. As I told you, or represents union. So you need to find probability of A union B. So what is the formula? Add the probabilities of A and B and subtract the intersection. Now you know all these values, 1 by 4 plus 1 by 3 minus 1 by 12. So just do the substitution, make the denominators equal. So here it is 4, here it is 3. The LCM will be taken, which is 12. So in the numerator you get 6. So that is 1 by 2. So this is how you reach to option B. Okay, very important formula. That's why you see my star mark. Let's move now to the next question. The last question for today, question number 10. This is a question on sets. So two sets are given to you, set A, set B, 1 and 2. They have been marked. How they are defined, let's see. This is the set of all x such that x is a real number and its square is negative. So just think about this. Can the square of any number be negative? Can it be negative? Is it possible? Not at all. Even if you take a negative number, take negative 1 whole square. What is that? Plus 1. So even for negative number, the square is always positive. So this set will not have any element x. So this is definitely going to be an empty set. So yes, 1 is definitely going to be an empty set. Let's look at 2, the set of all odd prime numbers. Now this is not empty because there can be so many prime numbers which are odd. Let me give you one example, 3. Another one, 5. Another one, 7. All of these are odd numbers. All of them are prime also. So these are definitely having so many elements, so it cannot be empty at all. So yes, A is